Quadratic graphs take two forms, the U-shaped, that is the smiley-faced, or the N-shaped, that is the sad-faced. The U-shaped graph is obtained when the coefficient of the x-squared term, that is a over here, is positive. Examples. The coefficients of the x-squared terms in these equations are positive. Therefore, when you draw or sketch these graphs, they will have a U-shape. On the other hand, the N-shaped graph is obtained when the coefficient of the x-squared term, that is a over here, is negative. Examples. The coefficients of the x-squared terms in these equations are negative. Therefore, when you draw or sketch these graphs, they will have an N shape. If the quadratic equation is in completed square form or factor form, then you may choose to expand them into the standard form to confirm if the x-squared term is a positive or negative. The quadratic graph could be anywhere on the 2D Cartesian plane. It could be entirely above the x-axis, entirely below the x-axis, crossing it at 2 points or touching it at 1 point, crossing the y-axis from the left or from the right, or even symmetrical about the y-axis. Before you begin with the sketching or drawing, attempt to find out if the coefficient is a positive or negative. In doing so, you will be able to at least confirm on its shape, that is U or N. Next, the features of the quadratic graph. Point number 1. The graphs never end, and therefore will definitely cut the y-axis regardless of which side of the y-axis they seem to be. Both these legs of the graphs are never ending, in that they will continue to increase in the case of the U-shaped or continue to decrease in the case of the N-shaped and eventually cut the y-axis at 1 point. How about the x-axis? Will they cut the x-axis? That brings us to point number 2. The U-shaped graph could be entirely above the x-axis, or just touching the x-axis at 1 point, or crossing it at 2 distinct points. There is no way a U-shaped graph could be entirely below the x-axis. These two ends of the graph will continue to increase and will eventually cut the x-axis at 2 points. Similarly, the N-shaped graph could be entirely below the x-axis, or just touching the x-axis at 1 point or crossing it at 2 distinct points. There is no way an N-shaped graph could be entirely above the x-axis. These two ends of the graph will continue on and eventually cut the x-axis at 2 points. Therefore, with the x-axis, you could have no points of intersection, 1 point of intersection, or 2 points of intersection. Point number 3. There exists a turning point. As you move along in the direction of the positive x-axis, in the case of the U-shaped graph, the y value decreases, reaches a minimum value, and then turns back up. This coordinate, where the y value is the minimum, is appropriately called the minimum point. Likewise, for the N-shaped graph, the y value increases, reaches a maximum value, and then turns back down. This coordinate where the y value is the maximum is called the maximum point. Therefore, a U-shaped graph will have a turning point which is a minimum, while an N-shaped graph will have a turning point which is a maximum. In coordinate geometry, we have learned that the gradient, that is steepness of the curve at a point, is given by the gradient of the tangent line drawn at that point. Applying that, we have drawn a tangent line on the left arm of the U-shaped graph, and moving along in the direction of the positive x-axis, the gradient of the tangent, hence the graph, starts off negative, decreases in its gradient, reaches 0 at the turning point, and continues with an increasing positive gradient. Applying the same on the N-shaped graph, we have drawn a tangent line on the left arm of the U-shaped graph, and moving along in the direction of the positive x-axis, the gradient of the tangent, hence the graph, starts off positive, decreases in its gradient, reaches 0 at the turning point, and continues with an increasing negative gradient. Turning points and change in the signs of the gradients are evidence of each other. Point number 4. The graphs are symmetrical about the vertical line that cuts through the turning points. This half of the graph has the same horizontal distance to the line of symmetry to the other half, which means if you draw any horizontal line that cuts the graph at 2 points, the perpendicular bisector between the points of intersection will run through the turning point, and it is the line of symmetry of the graph. This is applicable to both types of graphs.